So I wanted to go over an example. Here we have a watershed of interest with four different lakes or reservoirs. We have the Upper Washington Reservoir, the Lower Washington Reservoir. There's Lake Stanford and Lake Lagunita. There are two streams flowing into these upper lakes that then split off into the lower lakes. And finally, they all converge into one river that leads out to the ocean or some other body. The government has built a hydropower dam on the discharge of the Upper Washington Reservoir into the Lower Washington Reservoir. So there's a lot of different streams and creeks, and depending on our question that we want to answer, we're going to look at them or not look at them. So here we have environmentalists are concerned about a given watershed, and they want to make sure that the outlet is receiving enough water. So they want to look over here. Define a control volume for this problem and calculate the watershed's discharge given the change in mass of the system is negligible. The given mass change of the system is negligible. Let me pull up my pen here. So we're really concerned about this output down here. That's what is feeding the deltas that maybe have smelt in them or something like that. And so if I'm interested in this area out here, I want this region, this arrow to cross my control volume because a control volume tells us what we're interested in. And since that's my output and I don't have any questions that I'm trying to answer about the exchange between all four of these lakes, my control volume becomes the entirety of this watershed. Let me see if I can change the color here. Yeah, there we go. The entirety of this watershed. And so now my control volume is a lot simpler. I have two inputs to my system, and then I have one output of the system. The question has told me that dm dt, the change in mass of the system over time, is negligible. And so if you remember to that first equation that we had, this is basically zero. That means my mass rate of change in, let's see, equals my mass out, my mass flow outwards. So that means if I add these two inputs together, if I add mass input 1 plus mass input 2, that's going to equal mass output number 3 over here. And that means our mass output is 50 cubic meters per second. 50 cubic meters per second. So you can see how using the control volume has allowed us to just look at the important pertinent information to this system. There may be some other outputs or inputs that we didn't consider, but this is just sort of an easy example of that. So let's move on to the next slide. Okay. So an energy company wants to make sure that the hydropower dam receives enough energy flows to generate electricity. Define your control volume for this problem and what information is missing to measure the given hydropower generation. All right, so another good one. So we're concerned, this question is asking about the hydropower dam here. And hydropower is generated by the flow of water through some turbine that generates electricity. And so our control volume is going to start here at least. I don't want to cut my reservoir in half because that's an easy thing to include the inputs and outputs of that system. So my control volume for this question is actually just going to be the Upper Washington Reservoir. I don't care what's happening in Lake Lagunita over here. I just want to know there's enough water to keep the flow at the right level for my hydropower dam. And so here we have one input and two outputs, and I'm only concerned with one of those outputs. So I'm actually missing the flows from the Upper Washington Reservoir to Lake Stanford to define my flow for hydropower generation. So that's what's missing. I have all the inputs tabulated for this question. Maybe I need to know the rate of evaporation of this reservoir. Is it really wide and shallow? That's going to mean there's going to be a lot more evaporation from that reservoir than a reservoir that's really thin and very deep, holding sort of the same amount of water. So you can see here, my control volume has dramatically changed based off of the question that I'm trying to answer. And based off of your question, you define your control volume, then you gather data that is an input or output of that system. And so that concludes my lecture today. Feel free to reach out to me if you have any questions, and take care.